Greetings, coding enthusiasts, and welcome back to the second course in the Intro to Programming series. I'm sure you're ready to jump right into some new programming topics, but before we do that, we're going to reflect on all the tools we learned about in the first course. We have a lot to discuss. The first course covered a lot of fundamental programming concepts, including calling functions, using variables with calculations, and making decisions with if statements. And I have a great project for us to work on that will help review these concepts and let us have a little fun too. The spaceship is bustling with activity because today we are doing some baking. So, put your chef's hat on and get ready to review the most important programming concepts from Intro to Programming. Today, we're in the ship's kitchen, preparing to bake some delicious treats for our crew. The kitchen provides various tools and ingredients, much like the tools you have available when programming. Let's break down these baking essentials into bite-sized coding lessons. Our baking adventure begins with the concept of calling functions. Recall that functions are like recipes. They contain a set of instructions that perform a specific task. Just like calling out a recipe name to start baking, calling a function initiates a sequence of actions in our code. For example, we may have this function called greet that will greet people as they enter the kitchen. If we want to call this function, we just say the function name, greet, followed by parentheses. When called, this particular function will print, "Hello, welcome to the kitchen." Now, let's see how to use parameters and return values with our function calls. Parameters act as inputs, providing essential information for the function to carry out its task. Similarly, return values provide an output that we can use in our code. For example, we have a function called add ingredients A, B, which takes the amount of two ingredients, adds them together, and returns the sum. If we wanted to pass in the values of 13 and 7 and store the results in the variable sum, how could we call this function? Try this in your guided notes. Using the parameters 13 and 7, we could call this function like this. The add ingredients function will now add 13 and 7 together, then store the result, 20, in the variable sum. In our kitchen, we have a pantry stocked with various containers holding ingredients. These containers work similarly to how variables work in a program. Variables allow us to store and manipulate data, making our code dynamic and adaptable to different scenarios. We just used the variable sum in the previous example to hold the number that was passed back from our add ingredients function. In past lessons, we've used variables to store text as well, like this. Ingredient 1 now holds the value flour, and ingredient 2 now holds the value sugar. We can then choose to print one or both of the variables using a print statement, like this. Now, let's talk about arithmetic operations, the building blocks of mathematical operations in programming. These operators allow us to perform calculations and manipulate numerical data with ease. We can use the subtraction operator, the addition operator, the multiplication operator, or the division operator. Also, you'll recall from the last course that we have the modulo operator, which returns the remainder after division. For example, 7 modulo 2 results in 1 because 7 divided by 2 is 3 with a remainder of 1. Let's try a multiple step example. Write an equation that adds the numbers 6 and 7 and stores the answer in sum. Then subtract 2 from the sum and store it in a variable named difference. Finally, let's calculate that difference modulo 3 and store it in remainder. Write the code to do this in your guided notes. Here's the answer. Now for a bonus. What will be contained in the remainder variable after this code executes? Try this one more time in your guided notes. First, we add 7 plus 6, which gives us 13 for the sum variable. Then we subtract 2 from 13, giving us 11 for the difference variable. Finally, we calculate 11 modulo 3, which gives us 2 as our remainder. When baking, we often need to adjust the heat of the oven depending on what's cooking. That's where conditional statements like if, elif, and else come in handy. They allow us to control the flow of our code based on specific conditions. We want to write code to print temperature is correct if the temperature variable is equal to 300. Otherwise, we want to change the temperature. Can you try writing these if-else statements in your guided notes? Pause the video here and give it a try. Here is the code. Compare it to your answer. But what if we have multiple conditions to consider? Nested if statements allow us to nest one conditional statement within another, enabling us to handle complex decision-making scenarios with precision. Take a look at this example. Here, we only check if the temperature is greater than 325 if the first if statement, if the variable ingredient is equal to chocolate, is true. Comparing ingredients in a recipe is similar to using comparison operators in programming. These operators enable us to compare values and make decisions based on the results. Here is a list of the comparison operators we've used. Let's use some of these. Can you write an if, elif, else statement to print the following? Print adult if the age variable is greater than or equal to 20. Print child if the age variable is less than or equal to 12. And otherwise, print teenager. Pause the video here and try this in your guided notes. Here is the code. Compare it to your answer. Finally, let's explore logical operators, which allow us to combine two conditions. They enable us to create complex conditions and control the flow of our program. We can use the AND operator, which becomes true only if both conditions are true. For example, if we wanted to increase the temperature of the oven, if the temperature is greater than 300 and the time is less than 30, we can use the AND operator like this. If we want to make sure that at least one of the statements is true, even if the other one is false, then we can use the OR operator. This operator becomes true if at least one condition is true. For example, we could check if the food variable is equal to donut, or the food variable is equal to cupcake. If food is equal to either of these variables, we print that it is time for dessert. Armed with these baking essentials, calling functions, managing variables, performing operations, and making decisions, we're well equipped to tackle a variety of coding challenges. All this baking is wearing me out. Time to take a break and play some tennis against my new tennis robot. I've been hard at work building this tennis robot, and now it's your turn to take on the challenge. The task at hand? Mastering the first return. Picture this. You're standing on one side of the court, and the tennis robot is on the other side, ready to serve. But here's the twist. Instead of aiming straight at you, the robot will be playing the ball with a certain drift, meaning it'll send the ball slightly off to the side. Your goal is to use the command hit drift to hit the ball back to the other side of the court. The parameter drift indicates how far sideways the robot will play the ball. For example, if the robot is given a drift of 5, it'll aim so that the ball hits the court on my side 5 feet to the right relative to its current position. Are you up for the challenge? Give it a try, then finish up the rest of the tasks in this section. And there you have it, a delicious recap of the first half of our programming course. Our kitchen adventure through the fundamentals of programming has equipped us with a robust toolkit that mirrors the essentials of baking. Just as in the kitchen, where recipes guide our actions, functions serve as the backbone of our code, enabling us to call them whenever we need them. We've learned the importance of parameters and return values, akin to ingredients and outcomes in our recipes, allowing for flexibility and customization in our programs. Variables act as the containers of our data, providing a dynamic foundation for our code to operate upon. We've discussed arithmetic operators, the building blocks of mathematical operations, allowing us to perform calculations with precision and ease. Conditional statements, from simple if statements to nested if, elif, else constructs, enable us to make decisions in our code, much like adjusting oven temperatures based on baking conditions. Just as comparing ingredients will guide our recipe choices, comparison operators allow us to compare two values and make a decision based on them. And logical operators, like the binding agents in our recipes, allow us to combine conditions effectively, steering the flow of our code with finesse. With these tools firmly in hand, we're poised to embark on exciting coding adventures, ready to tackle challenges with creativity and confidence. Whether we're baking up a storm in the kitchen or crafting elegant solutions in our code, the principles remain the same. Attention to detail, thoughtful decision-making, and a dash of creativity make all the difference. So, let's roll up our sleeves and dive into the world of programming with enthusiasm and gusto. Now, it's time to apply what we've learned and continue our journey toward becoming proficient programmers. Coding is like baking. The more you practice, the better you become. So, let's fire up our code editors and get cooking. I mean, coding. See you next time.